Previous session we have discussed about the pin diagram of microcontroller. So now let's see the continue with this reset circuit of microcontroller. So most of the cases every microcontroller, if you want to use for applications, so you need to do some standard connections or you need to do some mandatory connections with the microcontroller. So for this you should understand what is this reset circuit and why you need these all external components across the pins. Okay. So from 8051 microcontroller, the ninth pin is the reset. So generally every product whenever you are trying to use, so they may provide one reset button compulsory. So what happens whenever you are operating that particular reset button for your application? So internally what's happening? The device which is allowing to execute program from beginning. So whatever it is running now, it is going to terminate that and allowing to execute from beginning. So that is the main motto of reset pin for every programmable device. The same way your microcontroller also having the reset pin across 9th from the 8051. So this reset pin which is changed from device to device, few controllers may have first pin, 10th pin, 12th pin. So don't buy hard because it will change according to the device. But every programmable device will have certain one reset pin compulsory. Okay. So importance of reset is also very clear. It terminates the current process or running process and allowing to execute from beginning. So why you need these external components across 9th pin from the microcontroller? So here they are connecting one external RC combination with the reset switch. So what happens whenever you are operating reset button? So whatever the program present in the memory, so which is keep on executing line by line or statement by statement or command by command. But whenever I am operating this, the execution which will come to the initial position or initial address, which means you are rebooting the product or rebooting your system. So if the device which is doing something and you are operating this reset button, if the device will take certain time to come back to initial address. So how much time it is going to take? So that's also very important. That should be calculated. So the time relation with this external RC combination, the time constant formula is very clear. The time constant equals to 1 by 6 into RC. So this is the formula they will follow for time constant, and based on the resistance whatever you are connecting here and based on the capacitance whatever you are connecting here in series, that will decide the reset time. Okay. So you can apply your formula or you can apply the values. So why you need to work with these specific values, 10 microfarad and 8.2 kilo ohm. So these are tested values. So if you want to go with any other values, you can proceed, but there is no issue. But this is the minimum time required for microcontroller to come to initial address. So wherever it is throughout the memory, so whenever you press the reset button, it takes this much of time in the seconds. So whatever the values or whatever the resistance here, you have the values for 1 by 6 into 8.2 kilo ohm, which is 8.2 into 10 power 3 and 10 microfarad, 10 into 10 power minus 6. This is the time taken by your microcontroller to reset. So without this RC combination, your device don't have sufficient time to come back to initial address. So that is the main motto of connecting external RC combination across 9th pin of the device. Now coming to 18 and 19 pins. So 18 and 19 pins from pin diagram, these two are oscillator pins. So the importance of oscillator is very clear from microcontroller, which is going to generate the clock cycles, and clock cycles used for what? Program execution. So without clock cycles your device is not going to execute any instruction. So because for fetching you need some clock cycles, for decode you need some clock cycles, for execution you need some clock cycles. And who is the source of clock cycles here? Oscillator. So, but the oscillator which will maintain certain frequency here. So frequency is also very important. Supporting frequency is also very important for oscillators. So 8051 family controllers supporting frequency is 4 MHz to 40 MHz. So there is a total range, but the working frequency is here 11.059 MHz. So this is for generating accurate baud rate in the case of serial communication. So they are working with this frequency. Otherwise you can choose 12, 24, 8, whatever you want, you can deal with different frequencies here. But 11.0592 megahertz is the reason for only doing serial communication feature properly. If you don't want serial communication, you can deal with any other frequencies in between 4 megahertz to 40 megahertz. And they are connecting these external capacitors here. So these capacitors which are used for reducing the noise, because if you develop any embedded product, every product which is working 24/7 like CC cameras or ATM machines or computers or mobiles, so these are working 24/7 while doing the long working because of environment parameters like temperature or any other parameter which will affect your device functionality. So if because of that heat or because of overheat or because of any other parameters, it may generate some noise. So if you want to filter that noise, you need these capacitors across this oscillator. So these capacitors are going to reduce the noise generated from oscillator. So the main motto again is, if any noise generated from oscillator here, that will disturb your program execution indirectly, because oscillator is the source for clock cycle generation. And 20th pin is your device ground pin, obviously. So you need 40th pin for power supply, which is 5 volts DC, and 20th pin for ground. And what about 31 pin from 8051? So this is EA part. So from pin diagram, we discussed about this EA functionality, which is external access. Whenever you are looking for external memories, then you need to use this EA enable. So, but this is active low pin. By giving VCC connection, it disables external access functionality. If you give this same pin for ground, then it allows to enable external access. So that in that case, your 39 to 32 and 21 to 28 as address and data lines, not IOs. So you need to fix that functionality, so that I am giving 31 pin to VCC. So this is the minimum connections required for 8051 microcontroller if you want to use for applications. So this is standard connections. Without doing these standard connections with the controller, you cannot proceed for applications. So this reset circuit is mandatory for any application you want to do with 8051 microcontroller. So applications means again interfacing. So I want to clear the fundamental thing about interfacing. So most of the cases, interfacing means you will tell that it is a connection between two devices. But just doing physical connection, it doesn't become interfacing. So as an electronics engineer, you need to understand whenever you are connecting two different devices. So most of the cases, you need to focus on the two important characteristics of two devices, which are voltage and current characteristics. So if you don't have the compatibility with these two characteristics, if you connect each other, one device will damage another device. So you cannot connect a 230 volts fan with microcontroller IOs directly. So what I said about IO lines are used to connect external devices, but still your IO pins are your IO pins cannot handle your electrical fan directly. But you can control electrical fan by using microcontroller, but it is not possible to connect each other directly. The physical fan, two wires connection with two IOs, it doesn't become interface. It's only physical connection. But if you want to make it a proper interfacing between two devices, you need to go with the standard characteristics of two individual devices. Voltage and current characteristics. So these two characteristics are very important, even though one parameter is matching, like sir, I took 5 volts DC motor. Can I connect 5 volts DC motor with direct IO pins? No. Still, you need to refer about the current rating. If current rating is not matching with the required device, don't connect each other. Okay. So that is the only compatibility. You have many chargers, like one laptop charger, you cannot put it for another laptop, because it may have different output voltage rating, which is voltage and current. So generally we will focus on only voltage parameter, but you should be very careful on current parameter also. If there is a high current to other device, if it is passing to the other device, it will damage the other side device compulsory. Okay. So whenever you are connecting each other, you have to take care of voltage and current characteristics both. So then only the physical connection between two devices, which is become interfacing. Still, in electronics, you have different characteristics devices, like you will take a simple LED. LED operating voltage is not 5 volts. Mostly you remember that 5 volts is a LED operating voltage, not, but it is not. It starts, LED blinking starts operating from 1.8 volts onwards. But if you connect LED direct with microcontroller IO, which will damage your LED, because IO pin voltage is 5 volts and LED voltage, operating voltage is 1.8 volts. So that is the only reason we are adding some series resistance in between LED and IO pin. So if you have the higher voltage than load requirement, you need to add resistors in between source and load. If you have lesser voltage between source and load, you need to use amplifiers. So that is our complete electronics engineering. Why you need DC to DC amplifiers, why you need transistors, why you need switching components, why you need boosters, why you need regulators. See, all the engineering basic stuff will help you in this application. So that's the main motto. Whenever you are attempting for interfacing, you have to take care of the two characteristics of two individual devices, voltage and current characteristics of two individual devices. So in the next sessions, we will proceed with applications and as well the features of microcontroller, timers, counters, interrupts and serial port. Thanks for watching.